In 2021, a gigantic flare around 100 times more powerful than any experienced in our solar system was recorded blasting out of Proxima Centauri, and some scientists think these bright outbursts would slowly eat away at the exoplanet's atmosphere. If it does have one, and wipe out any water that may be on its surface. So although Proxima B is within the so-called habitable zone, its close orbit to its small star means it might not be very habitable at all. It would need a thick atmosphere and a strong magnetic field that could hold its own against extreme radiation that is up to 500 times more harmful than what we experience on Earth. On the face of it, this type of environment would strip atmospheres, evaporate oceans, and fry DNA on any planets close to a red dwarf. Yet it turns out that Proxima B might not be a dead world after all, because Earth climate models are showing that rocky exoplanets around red dwarfs can still be habitable. Scientists using a supercomputer created various climate models in a 3D simulation, revealing what a planet's climate is like based on specific conditions and environmental changes. When they simulated the possible climates on Proxima B, they found that the exoplanet could still be habitable despite being tidally locked, with one side exposed to heavy amounts of radiation. With an atmosphere similar to modern Earth and a strong magnetic field that deflects the extreme radiation, it is being bombarded with Proxima B, may well be covered in an ocean that extends to the night side. If seen from space, it might even look like a giant eyeball staring into its star. Have you ever wondered when you look up at the stars in a clear night sky, whether life on another planet is looking back? On the face of it, the galaxy looks to be eerily silent. We have not detected any signs of life as of yet. However, the search for life beyond Earth is really only just getting started. Even within our solar system, it is now thought to be a possibility that life could have independently sprouted up in a few different places, such as Jupiter's icy moon, Europa, or Saturn's shrouded moon Titan, for example. Could there be a planet beyond our solar system where life has flourished, and where we might realistically one day be able to visit? Well, it turns out that planet could well be located right next door, a world similar in size to Earth that is orbiting the closest star to the Sun, Proxima Centauri. And although it is likely being bombarded by radiation from its star, this neighboring planet could still be a promising place to search for alien life. The star Proxima Centauri is an odd one by any measure. It is part of a triple star system, where the two main stars called Alpha Centauri A and B are roughly sun-sized and orbit one another relatively close by. But Proxima Centauri is a small, long-lived, low-mass, cool in temperature red dwarf star that is so dim you can only see it with a powerful telescope. It is, however, the closest of the three, at just 4.2 light-years away from the Sun, and it is where at least 3 exoplanets have been spotted, 2 of which are confirmed, and 1 of which is located within the habitable zone of the star, the region where it's not too hot or too cold, where liquid water could exist on its surface. Proxima B was first detected in 2016, and at the time it created a lot of buzz, mainly because of where it is located around its star, but also because it is roughly the same size and mass as Earth, most likely making it a rocky world. The hope and speculation at the time was that it might have an Earth-like atmosphere, the same raw ingredients and elements as our world, and most excitingly, perhaps even life on the surface. However, as further research was completed, it became clear that Proxima B, although sharing some similarities with Earth, is experiencing a very different path, because Proxima Centauri is a small red dwarf star around 14% the diameter of the Sun. It is substantially cooler. This means that despite being within the habitable zone, Proxima B is a lot closer to its star than Earth is to the Sun, over 20 times closer in fact, making 1 year on Proxima B only a mere 11.2 Earth days. You might think that a smaller star would be a calmer star, but that's actually not the case at all. Red dwarfs produce violent solar flares a lot more frequently than the Sun does, because their nuclear fusion cores are much closer to their surface. This makes their surface much more chaotic, resulting in incredibly strong magnetic fields. In turn, those strong magnetic fields can blast intense high-energy radiation into the surrounding system. And because Proxima B orbits so close, it is likely being bombarded with space weather that is far more violent than what we experience here on Earth. Proxima B is also most likely tidally locked in a synchronous rotation, meaning that one side is always facing the star and one side is always facing away, much like our Moon, where one side always faces the Earth. On Proxima B, this would result in half the planet being bathed in perpetual daylight, while the other half is in a never-ending frozen nighttime. The sun-facing side would be constantly exposed to high levels of radiation and possibly even blasted with solar flares. How much of the planet this ocean covers would depend on the amount of salt in the water, as this would lower its freezing point and allow it to extend into colder regions. But even if it has high salinity, with a thick atmosphere and a strong magnetic field, an ocean is possible according to these simulations. And if the right ingredients are also present, then Proxima B could theoretically host life. If we look at the Earth's Dead Sea, microbial life has found a way to thrive there despite a salt concentration above 30%. So it's not impossible for salt-loving life to likewise exist on Proxima B in this scenario. The simulation also revealed that thick clouds on the star side might act as a massive umbrella. This could help to deflect even more of the star's radiation. And with a combination of atmosphere and ocean circulation, warm air and water could move around the planet, transporting heat to the cold side, keeping the atmosphere from freezing and creating regions that maintain liquid water, even though those parts never see lights. Of course, although this research is exciting, it doesn't tell us whether or not there actually is any atmosphere or water on Proxima B, or even if it ever had any. But if the exoplanet formed very wet, then there is a possibility that water still persists. It may also have started out further away from its red dwarf star and slowly moved closer, providing protection from powerful flares in its early days. While conditions on Proxima B are certain to be very different from here on Earth, alien life could exist beneath such exotic skies, and they could see a plethora of landscapes such as frozen wastelands, rugged mountains, parched deserts, or oceans from horizon to horizon. So friends, what are your thoughts about this theory? Share them in the comments section. If you enjoyed this video journey, then like and share with Cosmic Explorers, and subscribe to my channel for more similar videos.